Welcome to part 3 of our live training session here with our 2003 Subaru WRX. In our last training tutorial, we looked at the fuel calibration process for working with a mass airflow and speed density style operation within our Carberry ROMs. In this training tutorial, we're going to be switching our attention over to the spark timing, learning how to tune our main spark timing table, and how to analyze and look at all of our data within our Megalog viewer to determine if we have knock activity and how far we can push our spark timing. Now, we're going to be on a chassis dyno for the training tutorial, but you'll be able to learn all the techniques in order to calibrate your spark timing without a chassis dyno. We're going to have a lot to cover and talk about in this training tutorial. Let's jump in so we can check this out. Welcome back to our live training session here with our 2003 Subaru WRX. In the last video, we went through the fuel calibration process for both mass airflow and speed density operation. So we've dialed everything in. We know that the MAF curve was valid. We know that our injector data was valid. So the flow rate and the latency were tweaked. We got that all sorted out. And we've also dialed in our volumetric efficiency table. So everything was sorted out, everything was driving very well, and we were able to do idle, part throttle, and full throttle pulls. Now the power output was extremely low out of the engine. We were running lowest boost possible off the wastegate actuator. In this case, it looks like it was building about 13 pounds off the actuator, and we had really low spark timing so that we could dial in our fuel tuning. This video, we're going to be jumping in and taking a look at the spark tuning process. Now, we're not going to go in and turn up the boost. We're going to take a look at how to do the boost control tuning in the next tutorial. But this tutorial, we're going to be focused on everything related to spark timing. Now, we shouldn't have to go in and update and tweak anything in our fuel delivery, but we might, so we're just going to be logging that when we're taking a look at all of our data. But this is going to be a start to finish of how to calibrate and work with our spark timing. The process is extremely simple. Now, let's just go through a couple things here before we jump into the logging and going in and actually taking a look and analyzing the data. So jumping in here, I want to talk about something that we left off in the last video, and I actually was explaining it and I was actually programming it here backwards as I was talking and setting up everything in here. So I want to go back over this and fix this, and then we'll go into, again, some of the spark timing that we need to go and deal with in this video, and then we'll flash it. We need to update the actual calibration file. There's some things that need to be updated and changed. So we're taking a look here. We're going to find under the MAF SD speed density blending mode, we have it set, and I left it set on the SD MAF blend. Now, when we were doing the previous tuning in the last tutorial, we started off with our mass airflow. We got that all sorted out. Then we switched over into pure speed density blend. We got our volumetric efficiency table sorted out. So we know we can operate in either mode, and it'll accurately estimate airflow within the speed density operation, or it'll measure the airflow in the mass airflow operation. We know both are valid in terms of our airflow registration. So now what we can do is switch this over to our speed density MAF blend. Now, this is something you may or may not want to do. I'm just going to go and do this because this is something I prefer to work with when I'm calibrating and tuning. I like to work with mass airflow for idle and part throttle. I find that it's very repeatable, and it takes a lot of the inconsistencies out when we're dealing with going in and giving our fuel delivery. But the speed density is something that we probably want to run when we're getting higher boost pressures, because we don't have to worry about maxing the mass airflow sensor out. It does have a certain amount of airflow that it can only flow at. Speed density has no ceiling on what it can actually register for airflow. Again, our volumetric efficiency table, this is an estimation of airflow. This is map pressure based. So if we want to go in and scale it to a higher reading map sensor, we can renormalize our breakpoints here to higher values and allow it to go and register higher and higher boost levels, and everything is going to be pretty straightforward and simple. The mass airflow can hit a cap or a limit on what that's going to register. Now, this has a stock mass airflow sensor. So what I've done, tune everything on MAF, tune everything on speed density. And then we were using the blend table here in this hybrid mode to be able to go in and tell the ECU which mode to register and run at. Now, what I did here, and I made a mistake in the last portion, the very last end of that last video, I actually went into this table here and I programmed this backwards. I want to just clarify this and fix this and reflash it here. So in this table, we'll find that this is the manifold absolute pressure, and that's going to be on our axes here. And then on the right axis, this is going to be how it deals with the blend ratio between MAF and speed density. If we have a value of 0 here, that means it's operating in pure mass airflow mode. If we have a value of 100, that means it's operating in pure speed density mode. I actually set this table up here backwards, where I'm having here in vacuum, so roughly 13 PSI absolute and below, which is vacuum, it was going to be running in speed density. And then as it gets into boost here, roughly 18 PSI absolute and higher, it was going to be at 0 running in mass airflow. I actually want to do the opposite here. So let's just go and flip-flop this. Let's set this to 100 here at our higher boost ranges. And let's go here and set this to 0 in our vacuum. So this is going to allow us to transition between these two operation zones. Now I did also tweak the breakpoints in the table. So I changed my PSI absolute here, and let's just go here and just set this to 14 PSI. So from 4.8 to 14 PSI absolute, which is essentially 0 PSI, it'll run in MAF mode. And then at the transition point, 14.5, it can switch from, it starting to blend from MAF to speed density. And then as it goes here above, and I program this to 18 PSI absolute, which is about 2-3 pounds of boost. Actually, it's about 4 pounds of boost. We could lower this down. Let's do equals. We'll do 16 PSI absolute. It'll switch to pure speed density. So in this transition point from vacuum to boost, it'll transition from pure MAF into pure speed density, and it'll have a blend point right around that. That's going to allow us to take advantage of the best of both worlds here. Again, the reason why I like to integrate a MAF sensor if you have a recirculated blow-off valve is because it simplifies the calibration and tuning process, and I also find it's much more accurate. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.